In this video, we shall discuss the first method or technique in analyzing games in normal form. Now, games in normal form are used to analyze simultaneous games. Recall that in a simultaneous game, each player chooses one action and all of them chooses at the same time. So how do we decide? We can use the following. First, we can use the maximum solution or the Nash equilibrium or the dominant strategy equilibrium. This video focuses on the maximum solution of the normal form of a game. This solution involves choosing the strategy that gives you the maximum among your worst payoffs. So this means that the decision maker is a worst case thinker. So for each strategy, the decision maker thinks of his worst possible payoff and then chooses the maximum among those worst payoffs. This was proposed by the mathematician John von Neumann. Let us discuss the process of finding the maximum strategy of each player by using an example. So let us suppose that we are analyzing the working on a project game. This states that you and your classmate work together on a course requirement and each of you can choose to either work hard or take it easy. You both want to pass, but both of you do not like working very hard. Assume that the two of you would meet tomorrow to combine your outputs. So let us determine the maximum strategy of the two players. The payoff matrix for the working on a project game is shown on your screens. The payoff values that you see represent happiness levels or satisfaction levels. So for example, if you will work hard and your classmate would take it easy, you will get 0 as happiness level and your classmate would get 3 as happiness level. This is very logical because you're the one who worked hard and your classmate just waited for an output. So that means your classmate would be much happier than you. In finding the maximum strategy of each player, we use the following steps. First step, we separate the payoff values of each player into two matrices. So this would be the payoff matrix of the role player. So as you can see, we rewrite these payoff values in this table. Now for the column player, we get this table. So the values that you can see in the second table at the right are the second coordinates in the original table. The second step consists of two sub-steps. The first sub-step is to find the maximum strategy for the role player. So to do this, we highlight the worst payoff in each row from the payoff matrix of the role player. Among the highlighted payoff values of the role player, determine the maximum. The strategy corresponding to this maximum value is the maximum strategy of the role player. Now let us consider the payoff matrix of the role player from the working on a project game. So from sub-step 1, we shall get the worst payoffs for each strategy of the role player. So now, if the role player would work hard, his payoffs would either 2 or 0. So the worst payoff here is 0. Now, if the role player will choose to take it easy, his payoffs would be 3 or 1, and the worst value would be 1. So among the worst payoffs 0 and 1, we get the maximum, which is 1. And this value corresponds to the strategy, take it easy. So the maximum strategy of the role player is T, or take it easy. Sub-step 2 is similar to sub-step 1. So this time, we're getting the maximum strategy of the column player. So to do this, we highlight the worst payoff in each column from the payoff matrix of the column player. Among the highlighted payoff values of the column player, determine the maximum. The strategy corresponding to this maximum value is the maximum strategy of the column player. To apply this, let us consider the payoff matrix of the column player. If the column player chooses to work hard, his payoffs would be either 2 or 0. The worst payoff here would be 0. Now, if the column player would choose to take it easy, his payoffs would either be 3 or 1, and the worst payoff here is 1. Now, comparing the two worst payoffs, we get the maximum. In this case, the maximum is 1, which corresponds to take it easy. So, therefore, the column player's maximum strategy is to take it easy. The last step in finding the maximum solution of the normal form of a game is as follows. If both players have a maximum strategy, then the game has a maximum solution. We write it as an ordered pair of strategies A, B, where A and B are the maximum strategies of the row and column player, respectively. So the maximum solution of the working on a project game is written as take it easy, take it easy. This is because the row player's maximum strategy is to take it easy, and the column player's maximum strategy is also to take it easy. Now, the outcome of the game would be the intersection of the two strategies. So therefore, the outcome would be 1, 1. So each of them will get a happiness level of 1. This is logical because both of them don't like to work hard, but both of them would like to pass the project. Let us have another example. This example is referred to as the Battle of the Sexes game. Suppose on a given night, a husband can either watch a sports program or a TV series. The husband prefers the sports program, while his wife prefers the TV series. The worst possible thing to happen would be to have an argument and not watch together, or at all. What should the husband do, and what should the wife do? Let us determine the maximum solution of this game. The payoff matrix for the Battle of the Sexes is shown on the given table. Now we let capital S be the strategy to watch a sports program, and capital T is the strategy to watch a TV series. Now suppose that the husband chooses the sports program and the wife chooses the sports program. So the husband gets 2 while the wife gets 1. These values are happiness levels. So the husband is happier than his wife because they are watching his preferred program. Now, separating the payoff values for the husband and the wife, we get the following tables. Now, analyzing the table for the husband, if the husband chooses a sports program, his worst payoff would be 0. If the husband chooses the TV series, his worst payoff is also 0. So if we get the maximum is 0, and it corresponds to all the strategies of the husband. So this tells us that the husband doesn't have any maximum strategy because it doesn't resolve the problem of choosing what program to watch. Now similarly for the wife, if the wife chooses the sports program, the worst payoff would be 0. If the wife chooses the TV series, the worst payoff would be 0. Now since the maximum of these values are or is 0, which corresponds to both the strategies, then it also doesn't resolve the problem of the wife. So therefore, the wife doesn't have a maximum strategy. Since at least one of the players the husband or wife does not have a maximum strategy, the battle of the sexes game does not have a maximum solution. So in other words, for a normal form of a game to have a maximum solution, both players should have a maximum strategy. So as an exercise, let us determine the maximum solution of the prisoner's dilemma game if it exists. So first step here is to separate the payoff values for each player. So for player 1, the strategies are to confess or to remain silent, and then we get the first coordinates. And for player 2, we get the following. So for player number 1, or for the role player, if he chooses to confess, then the worst payoff would be negative 10. If he chooses to remain silent, the worst payoff is negative 25. Now the maximum between these two, between negative 10 and negative 25, is negative 10. So which means that the maximum strategy of player 1 is to confess. Now for player 2, if player 2 chooses to confess, the worst payoff would be negative 10. And if player 2 remains silent, the worst payoff is negative 25. So the maximum between these two values is negative 10, which corresponds to the strategy confess. So in this case, since the two players have maximum strategies, then the prisoner's dilemma scenario has a maximum solution, which corresponds to confess, comma, confess. And the outcome of the game would be negative 10, comma, negative 10. So this is the analysis for the maximum solution of a normal form of a game. In the next video, you will learn the second method or technique in analyzing the normal form of a game.